Doing it right now.
Recording in progress.
All right, we're gonna start binary search tree. This is module 6. If you go to the notes in module 6, we're gonna build this tree right here. So a binary search tree, you notice like if I just ignore like half of the left half of this, I just did 8, 10, 14, 13. It's kind of like a linked list. A binary search tree allows us to sort, do it like a tree where it sorts and does stuff left and right. You'll notice the way this is going to be an integer search tree. You'll notice the way it works is that whatever the number is at the start, if the number is less than it, it goes to the left. If the number is greater than it, it goes to the right. So like 3 is less than 8, so we put it to the left. And then 1 is less than 3, so we put it to the left of that. It looks like 6 was installed after 3 was, so it goes to the right of 3. It doesn't rearrange the tree to put it in order. We're going to use everything you've ever learned. Well, maybe not ever. But there is definitely going to be some if shit going on. They are back. I didn't fire you. And he doesn't pay your fucking... He doesn't sign your shit. So let's copy this stuff and we're going to go put that. You will see when we copy this. All right, rein it in. Rein it in. He's late. Ignore him. Both of you. No, it's not your fault. They're acting up. I'm silencing them. It's Josue's fault, really. All right, so let me put another little line in here. This is CSCI 02, spring 2025. Day 16, we're doing our search trees, binary search trees. So you will see we have a node set up that has not just a node and a node pointer to a next thing, but it's going to have a left and a right. And it's got 2 more things. We'll look at the binary search tree in a second. Notice the main is completely empty. We're going to just do everything from scratch here. And all we've got on node is it looks like we've got a find depth, like how far down the tree it is, and a report. And we'll look at report after we've got some stuff in. I am going to, let's go back over to that other thing. I'm going to write down that tree. What? What do you mean, what model? Module 6. This is what happens when you don't pay attention in the beginning. Josue. Module 6, notes binary search tree. I'm going to write down this because we're going to do, rather than having to tab over to this several times, I'm just going to write down this little, we're going to build this tree right now. And then we're going to like look at it while a report is running and figure out how the report works. And then we're going to build this up.
I don't know what you people bring in, but I. Oh, you people? I remember that. He gets it out and he get away, and I wasn't using it all the time.
You were fucking doing that shit when you walked in. It's the fucking weather.
Yeah.
Fucking thank God. Normally my allergies have been fucking acting up like by the beginning of March and nothing so far. Fucking. The only thing I can think that's changed is I've started using a CPAP machine for sleep apnea, which has me breathing filtered air at night. But I'm breathing unfiltered air all day. Either my allergies just suddenly fucking stopped, and that would be fucking remarkable, or the fucking machine I hate at night is fucking making my day so much better. Look at, what the hell? Let's do autofocus on this. That's not what I said at all. I gotta close that and restart back up.
I'm sorry that
Don't fucking apologize for no fucking reason. We've talked about this. All right, there we go.
Is it manually, like, actually making a rotation, or how are you able to do that?
I'm using this little thing right here and it is fucking doing its own little focus thing.
Oh, so it's not the actual camera when you do that? does it
No,
actually
see this? I'm grabbing this thing and I can wheel it around in a circle. I can do this shit like this. I can do it like this.
So, wait, but does that actually affect the camera?
No, it's just changing the way it's, do you see the camera moving? It's just changing the angle it's interpreting it.
That's really cool.
All right, so that's what we're gonna use. I'll move that over when we need it some more. Let's look at this a little bit more thoroughly. So we've got our node, we got a left and a right. We're just gonna do a data. Fuck data, I'm gonna go with value. I'm changing mine to say value.
What did you copy and paste this?
Module 6,
I'm sorry, I didn't listen, sorry.
and it says notes on binary search tree.
You go so bad.
Evan, did you have a problem finding it? Nope. See, Evan wasn't running his mouth. Evan was paying attention. He wasn't running his mouth. And you're listening, you let Josue distract you, Carlos. That's what the problem is. Why? Do we? Ah, yep. I'll leave it as data. Fuck it.
Data?
Yeah. You're right. It did change shit. All right. So what does our binary search tree class look like? It's got a root, which is, I'm guessing, not guessing, I know. Root is the top of the tree. Like if you made a tree, if we did the tree, because Carlos likes to see the shit go upside down. If I made it look like an upside down tree. Going the wrong way. It looks like a tree growing upwards. Well, that's just because I didn't make a long fucking. If I make a long. I already got it rotated. No, I don't. Yeah, I guess it kind of does. It does kind of look like the roots of the tree. But we're gonna call root the top one. And we got to find depth. It looks like we got in here some stuff to make a request to make a print function, an add node function, insert node function. Let's hard code this bad boy up. So I'm going to make a node pointer. I'll call it temp. And do we have a constructor on our node thing? No, we don't. And so I'm going to say temp.data. Let it turn to a pointer equals 8. I will say temp.left equals a null pointer. And temp.right, or arrow right, is also a null pointer.
I missed the whole thing of you could just cut. Oh, this is.
We are gonna put in some accessor methods in a bit, but you need to see like it helps to see the stuff hard coded out to make the accessor methods. And so we've got a class called binary search tree. Well, let's just make a binary search tree. What do we want to call it? Our tree. Our treehouse. There we go. Nope, I just want it really short. I don't want to have to type a lot. We're going with our tree. And our tree has in it what? It has just a root. And it's a pointer. So at this point, I'm going to say our tree.root equals I gotta do it. Yeah, equals 10. All right, so now we've got our root. Do we want to go down the left branch or the right branch first? Let's go left. Okay, so we're gonna do the 3 is next. Next, install the 3. So I'm gonna say temp dot left. We're gonna make it a new node. This would be a lot easier if I had a constructor here, right? Let's make at least a constructor for node. Int arg value. I've been wanting to use value. Come down to our bottom and we'll prototype that bad boy. Don't forget your scope resolution. And we'll say set, nope, data equals value. That's good enough for now before we make all our accessor methods. That should make it so we can set up a new node real quick. We're gonna do that in a second. Got to see what the tree looks like while you're building it because it helps with everything else.
Yeah.
All right, now that we got a constructor in, now I can say new node. And we're putting in a 3. And now I can let temp equal temp dot left. And we're gonna make temp now we're at 3. And now we got to make those null pointers left and right. Temp dot left equals null. And temp dot right equals null. I need to quit saying dot because that's not how every IDE works. Bad habit. All right, now we got 3 set up. And now we're gonna, well, let's keep going left. So temp left. We're gonna do a new node. Now we're gonna install 1 here. And I'm going to jump to it because that's how we're going to normally do shit when we're like, if we build the add node, we're going to have to do it the hard way. So let's see what the hard way looks like now. Temp equals temp left. And now we'll say temp left and temp right are null pointer. So right now, temp is pointed at 1. And our fucking thing just keeps fucking auto-focusing all on its own. So our temp's there, and to do 6, we're going to have to restart. We're going to have to go back up to the top. Now, I'll tell you right now, you're like, we did previous on doubly linked list. Previous is fucking fantastic. It makes it a real bitch when you're trying to do like insert node. It really does. When I was doing this class, it took me, I want to say I spent 16 hours getting fucking, as soon as I put previous in, being able to go backwards up the tree. You'd think it'd be so fucking easy. But as soon as you try to, like, if you want to rearrange the tree, Cause we might have a tree, if we put in the numbers in the wrong order, we're gonna have something that it's all just a one-sided tree and it looks like a list. And if you wanna make it balanced where the search just takes less time, where it's evenly down each way, you gotta be able to rearrange the tree. And that means pulling shit and reinserting it, and if you've got previous in there, it's fucking hard. You gotta test, like all sorts of shit on it. Every time I thought I had it, I tested different in a different spot and it fucking didn't work. All right, so to do this, well, we've got a print function. Let's make sure this is working. In fact, let's do it right here. Let's start. I'm gonna do a little C out with a little spacer. And I'll copy that, and then we're gonna do a report between it. And report, is report a node function? No, it's a node function. But root is a node, so I should be able to say our tree dot root dot report.
What I'm understanding is that, the root tree is just keeping a pointer, kind of like how we do a head pointer.
It's exactly like a head pointer. You don't wanna lose the root. Gotta have the base of the tree.
Okay, I find it weird because it's a separate file.
Oh, the binary tree.
Yeah.
Well, we're gonna have some more methods in there. We don't have a lot in here, but like the tree has stuff that the node doesn't. The tree is just like one of the points on a tree. All right. That's not what I didn't want to type it there. I wanted to type it en route up here. There we go. So I'm gonna copy and paste that print function a couple times. We'll put it between each one, make sure it's working. I don't want to go further until I know it's working. If I do it after each one, I can see what's going on as it builds it. And that's why you do it right. I should have done it earlier. What I got going wrong here? I guess I can do 8 at this point, since we made our constructor. Comment out that line. Get rid of that line. Bless you. Just an intention whore over here, isn't he? Shit ain't printing. What's going on? Did I- What? No, I don't. You're right. Oh, there it goes. It was just. It's just being a little bit. Oh, I need an end line in there.
So what do you do to fix it?
I just reran it. I- What?
You said, you put it out, it's like, how is it?
On the root. I want that end line in there.
No, I'm wondering is, because I'm trying to run it, it just give me the local variable temp.
You might not. I did you. If you look here, we did the change this to say new node 8 at the start. You may not have that.
Yeah, because now we're using a constructor.
I never declared temp was a node. I just started using it. All right, let's run it, make sure it looks good. So it goes 8, and then it goes 3, 8, and then it goes 1, 3, 8. All right, so now we gotta get to 6. We want to put in 6. So I'm gonna say temp equals root, our tree dot root.
I'm more surprised that we aren't putting left and right is equal to no time with the structure. I would find that easier.
We're gonna do that.
Or-
It's okay. It is easier, but like it's easier to, when you see, have it all listed out in the main, what's going on, seeing how to generate an add node is a lot easier rather than just saying new node. Yeah, it's baby steps. And so right now I'm making temp equal root, but I don't want it to equal root. I want it to equal 3. So I'm going to say go left here. So this should take us back to node 3. And now I can do temp dot right or arrow right equals a new node. And we're going to make it 6. And we'll copy and paste the temp in. Oh, wait, I got to jump to right first.
It all seems like a ginormous mess.
Well, didn't the linked list look like a ginormous mess when we started?
No, I don't mean like looking at it right now. I mean like processing, like just looking at the when you actually start doing the box method of double checking.
Okay.
Just because you have to like review this, you have to make sure, and like how you tell us by now that previous will be annoying. I could just look at it and just realize, yeah, it's gonna be way more annoying.
So as Carlos is pointing out, we're going to leave this part where it says temp left and temp right in there saying null pointer, because now we've got a few nodes done that way. Let's go put that part in our constructor for node. If I add that in right here, it's not temp, it's
You have to put it in the
left equals null pointer and right equals null. Because that's where they were labeled. If we go back up to node, it was left and right. So now when we add later nodes, that'll speed up a little bit. So here we put in 6 and here we jump to 6. Let's turn off zoom, or not zoom, but God damn it. There we go. Okay, so we're at 6. Now let's make a note on 4. Do I gotta log out? Exit Steam. There we go. So let's make 4. I'm gonna go temp left equals new node. And we're putting in a 4. And now that we've seen how the jump process works, I'm not actually going to jump to there and have to jump back to the 6. We've seen the jumping a few times and having to reset back to root. Let's just go temp right equals the 7. And we'll do another report. We put the null pointer in with the new node. Sped that up a little bit. I'm not gonna get rid of all the previous stuff because I want to see it there for when we're doing our other stuff. But let's run it, take a look. So we have the 8, the 3, 8, the 1, 3, 8. I could do it between the 6, the 4, and the 7. But notice that when we're reporting, it's actually printing it out in order, which is kind of neat. Let's go back up to root and build the right side of our tree. So temp equals our tree.root. And we'll say temp right equals new node. We're throwing in a 10. And then we got to jump to temp right. So now we're at 10. And now 14 is larger than 10, so 14 is going to go to the right. We'll say temp right is 14. And to put in the 13, we're going to jump over to it. And finally, we'll add 13 is less than 14, so we're going to say temp left equals new node 13. And we'll print out our root again. Now, this report function, if you look at it, it's really fucking short. Let's go down and look at the report function. Everybody with me got the full tree installed? Yeah, you're not even coding, so I'm not worried about you. Oh, well then why are you not? If you're not,
When you scroll up and down, I get.
okay, you can see the tree over here on the right, and it stayed there the whole time. So where did I lose you? Yeah, I can read that.
That's fine, Sue.
I'm not caught up.
Give everyone a second to get caught up. How you online doing? Who we got online? Gladys and Triumph? Yeah. All right, so let's come take a look at what report is doing. If left, do left report. Then it does see out data. If right, right report. So I've been running our tree.report. Our tree.root.report. That's what I've been doing. So this looks like it's doing a recursive call, right? It's calling report again. So let's see what's going on. Let's track a little bit, follow what's going on a little bit. So how far down can I go? There we go. So when we first run it, we're at the 8, and the left does exist. We're at 8. A left does exist, so it goes left report. And going left is jumping to, maybe I should just put the node there. There we go, put the node there. And this causes us to go to 3. My fucking tree just blurred the shit out. Why does it keep auto-focusing? Okay. At 3, we do have a left. So when we say left report, I'll say left rep, it takes us to 1. At 1, left is null, so it can't jump left. So here it actually does a C out of the data. So it prints to screen. This is where it prints to screen. Oh, I'll do print to screen right here. It prints out the 1. And then it goes, okay, we're at the 1. Then it goes write report, but write is a null. So this one shuts down at this point. We've gone through 1 and it kicks back down to here. And the next line here was C out. So it C outs the 3. And then it does write report. And write does have 1. So it goes over and goes to 6. 6 has a left. So 6 left jumps over to 4. Left here is null. So it does a C out of 4. Quit fucking Jesus. There we go. Make it manual focus so it quits fucking auto adjusting. Gotta fucking be smarter than the goddamn tech.
So what I'm understanding is that this, so by just leaving left, if it's non-null pointer, it will actually just do that?
If it's not null pointer, it just keeps going left until it can't go left no more. When it can't go left anymore, it does print out. So here it prints out the 4, and then it goes, all right, it goes right. That we have a right. Right is a null, so 4 ends, kicks it back to 6. 6 does a C out. And we go right on 6. And we do have a right on 6. So right takes us over to 7. 7 left is null. It does a C out on 7. Right is null. So our report for 7 ends. It falls off the heap. Goes back here. 6 is done. It falls off the heap. It goes back here. Right, we already did that. We're done there. And we're all the way back to 8 where it does a C out here. So it does a C out on the 8. And then we'll do a right. It does have a right. So it goes over to the 10. And I think we can, everyone good with how this is going?
So,
We don't need to see the recursion anymore.
so what this does, essentially, it does everything on the left. If the left has a right, it will do that afterward.
Yeah.
And
So like following the recruiter, like it looks fucking, this seems like really short when you're looking at it. You're like, there's no way in hell that's going to fucking print out the right shit. But if you do a recursive trace on it, it fucking works pretty well.
And something I'm understanding is once it finishes with the left side, it prints the very first, box of the tree and then goes to the right. Right?
Yeah, it goes all the way down to the left, it prints, and then it backs up, prints, checks right, and it just keeps doing that. Now, what would happen? Let's make a new report here. I'll call it report WTF. We don't know what it's going to do yet. Let's just change the order of these. I'm going to put the left here and the right up there. And I know I got to make a report what the fuck up top as well. So all I'm doing is going to swap the order of these and we'll run that as well. Take a look at it. So I called it report WTF. Put it here, void, report WTF, void. And I'll go back down. Make sure you prototype it up top in the node thing, but
So we are making a new one, but called WTF instead?
yeah, because we don't know what it does. Well, I know what it does, but you may not know what it does. You can call it whatever you want. Report, I don't know. Can we put a report question mark? Will question mark fuck it up? I think it might.
So we just put in the, you know,
All I did is switch the order. I put the right one on top and the left one on bottom. And I'll go up and I'll copy this again and I'll do report WTF. And it didn't do what I thought I was going to do. What did I fuck up? Oh,
so it's
I was not doing the right I didn't fucking change the recursion. I had it calling it a completely different report. It's not recursion if it doesn't call itself, right?
Oh,
And now when we run it, it should be going backwards. Which was probably expected, but now we could make it look crazy and we could say if right or if left, right report, and if right, left report. Let's see what that does. I'll change it back in a second, but let's just see what this madness looks like. Oh, it told me to go fuck myself.
it just got too.
It didn't like it right there. It's like, nope, that's not gonna work for me. Stop.
Is it because you have it less than right inside, left?
It's because it's probably access memory that wasn't there. So
Yeah, I'm telling it, like, there's no right to report. So that madness doesn't work. I'll put that back to right and left. Right? All right, so maybe we can change the report WTF to change it to say report backwards. Report back. Don't put the parentheses in because then you're gonna have to go change it and it'll look different up top. But if I do replace all, then now it will have exactly what it does rather than who knows what it does. Hold down the control key and hit F. It's control F or control find. Okay, so let's go and put in some accessor methods for our nodes before we do the add node or add node in the tree. Let's do like a get data and set data. So get data should return an integer. And set data doesn't return anything. But it takes in a value. And then we'll do a get left and a set left. And same thing with the right. And pointer and get right. Void set right. So I'll pause there for a second, make sure everyone's gonna set up the same ones I am. You can name them however you want, but we're just making accessor methods for the things we have real quick.
So we just start making seven that function.
Yes. What do you mean when? As if you remind, if we have time at the end of class, I'll copy and paste it at the end of class.
No, I mean,
Whenever it's done recording, it might be, I'll probably be doing it tonight because I got work I gotta do tonight. The hustle never ends. I gotta grade your guys' shit. That's not even what I'm doing tonight. I'm making some tests for another class and then I'm writing some fucking recommendation letters for student of the year for graduation for students that are graduating. Yeah. You don't get one. You're not graduating. All right, so I got those up there. Let's come down and build them. So we got to make sure we do the scope resolution. So I'm going to grab that and just put that in front of each one real quick. And then I'll populate it. So get data should just return data, right? And set data should be data equals value. Get left will return left. And set left left equals new node arg. Why is that not like that? Should be all right. Maybe it's just being moody. Turn right. And then right equals new node arg.
Oh, no, he was having issues. In the wrong place for the wrong thing. Trying to return things on the wrong. That's what that's probably good.
Why is that not working? No, because that would be assigning left. Left should be left is a node pointer. Left is a node pointer, so it's setting a data value Let's try this. Where are we? Temp equals new node. Dot arg, we'll put in arg, and then say left equals, that's still not doing. Let's comment that out.
Shouldn't it just be left is equal to?
Nope, I didn't do it.
Shouldn't left be equal to arg?
No. Arg is a number here, and left is a pointer. New node should be making a pointer out of it. When I run it, what? Oh. Okay, let me hit stop there. Okay. You're right. This should not be a node pointer. This should just be an arg. And I'm gonna have to go up and change the prototype up above. Everything run. There we go. Okay, everything. Why did output jump to its own fucking thing? All right, well, fuck it. Fucking just detached itself. Oh well. Okay, so now that we got that, everyone's working, that's doing it. Let's go make an add node function. So let's make like a new tree here. Let's figure out what we want to have here. Carlos, give me a number.
5.
You want what? 10. 20, 27? 27 there.
19.
17. 18. That's good. Let's do that. So we're going to start off with, that'll be our root. We're just going to put them in the order we got. So let's see what the tree should look like. If I do this, I put the 19 as my root. Get rid of that. 10 should go to the left. 5 should go to the left. 27 would go up here. 17 is going to go to the left of 19 and then to the right of 10. And 18 should go to the left of 19. It's to the right of 10. It's to the right of 17. It should go like this. So let's work on making an add node function here. So it's not going to, shouldn't return anything. So we'll just call it a void, add node. And it looks like we want to pass in, and we saw by making an argument, the stuff above, we want to pass in an integer. We saw if we try to pass in a node pointer, the way we want to do it is just fucking shitty. Bless you. So, and this is under binary search tree. So when we go down below, we got a prototype or do the scope resolution with that. I feel for you, man. Fucking allergies suck ass. All right, so what was the first thing we did when we were making a linked list and we were starting something? Anyone remember?
And we started doing this.
When we put in our, like, when we tried to do an add node, what did we always check for first? If the head was null. So here we're gonna do if root is null. So we'll say if root equals null pointer. I guess we can say root equals new node arg. Right? That'll cover the base case. What are you nodding? You just walked in. You didn't know what we're doing.
No, it's saying
Oh. Okay. So that's our base case. We'll have an else. What does it do otherwise? Well, every other time we had like a temporary pointer, so maybe we should make a temporary pointer equals root. We'll just call it root. So temp's pointing to root. And so let's say our 19 is in. Let's say we've already done the 19. So we're passing in, the next number we're passing in is 10. So we need to check if 10 is less than 19 or greater than 19. So we should have, if arg is less than temp.data, temp.getData, and so if that's the case, we're going to the left. We want to go left. Temp equals temp.left. But temp.left doesn't have anything there yet. So maybe we need to check to see if it's a null pointer. Let's make another node here. That way we can check ahead and let's call it current. Current equals root. And we'll say while, let's have one of them be the node that we're looking at and the other one be the next node and deciding whether or not it's a null pointer. Because that's going to affect what we want to do. Do we want to make temp the node we're at and current the next one? No, that doesn't make sense. Current should be the node we're at. So we'll say while temp does not equal null pointer. But
Did we also just use one node pointer and use temp get left or go right? Maybe? Wait.
well, let's do it this way, see if we can refactor. Because that's a lot of mental gymnastics going on there. And I know we can do it too. So let's see. Temp equal, let's say temp is not null pointer. So we're going to say current equals, before we jump, we'll say current equals temp. And then temp will jump to the left. That way, current's always the one we're currently at. Temp equals temp. We're doing get left. We set up our accessors. In fact, we're gonna have to do current equals temp either way. So maybe put that above the loop. And then we'll have an else. I don't need to say if arg is greater than, it's either greater than or less than. So we'll just say else temp equals temp dot right. Get right. Get right in the head, son. So current is the one behind. Is this going to work? Yes, because if we jump, like right now, if we're at 19, so this is, they're both set to 19. This sets to 19 also. It's already set to 19, but this sets to 19. And then we go, okay, is 10 less than temp? Get data, 10 is less. So temp jumps to this. We're jumping to a null pointer here. This is tracking our first loop. And then we get to the while, it's not the else category, so it did the F. We go back to this, and the temp now does equal null pointer, so the while loop's done. So this is where we're going to say temp equals new node. Let's make sure that works, reason out our logic on the other ones. This should, if we do it on 10, it should put in 10. And now let's see what happens when we go through 10. Temp equals root, which is at 19. We're trying to put in a 5. Temp is not null pointer, so it checks 5 is less than 19. So it's going to go temp equals temp dot get left. Temp is here, and current is here. So let's see this. Current's my black pen. Temp is my green pen. And we go to the top again. Temp is not a null pointer. And so we go, is 5 less than 10? Yes, it is. Oh, no, wait. The first thing it does is it changes current to match 10. Then it goes 5 is less than 10. Temp jumps down to here, but that's a null pointer right now. That should break the loop of the while loop, and that should put in 5. I think this is going to work. I think that might work for add node. We're not returning anything, so what?
I was going to say, like, doesn't this mean, like, once it pops in and this is a given one?
Okay. I'm going to turn off all these COUts that we did before. Don't need to clutter it with a bunch of shit that we don't want. We're going to make a new tree. Fuck it. Why am I doing that? Just comment out the whole fucking thing. Second tree. And second tree dot root equals temp. We did had an 8 up above. I'm going to change that. Temp dot set data. We're going to change it to 19. Okay, now this is setting up. What?
You're sharing a tree.
We're gonna start a new tree. In fact, do I even need to do that?
Because you're sharing the node and one tree with the other node.
Yeah, I don't want to do that. Let's just do second tree add node. Let's see, make sure it works with root. Second tree dot add node. We're passing in a 19. And I gotta change this to say second tree. Make sure the first part runs. Where's my error shit?
You know what? Respect.
What?
He came back just to push it through share. He was already outside. You'll probably access you some sort of node. I have.
Let me hit run again, see what was going on. Get that out of the way. So how far is it getting? Because I don't know that we'd use get data anywhere. Where the fuck did we use get data? I know. No, we didn't use the constructor. All it is. Oh, the report. Report does get data.
Somewhere along the line, there must have not been an opening at the very end of the, maybe at the add node. Oh, that's probably what it is. Wait, no, because we have a constructor and it goes nothing.
Yeah, so let's look at our add node. If root equals null pointer, and it does.
Oh, it's right there. So there's your get data, line 1.5.
But we shouldn't have even gotten to that. We should have been in the 117. We don't have a default.
Root was equal to like actually nothing.
Yeah, we hadn't done anything yet.
So in the constructor of the binary search tree, you have to do a null pointer.
Yeah,
That's cool.
so that's clear that we've got a problem here.
We can do it in constructor, and then just solve it out. The default constructor, which is such way to null pointer.
Yeah. So let's come in here and make a constructor. And what is our binary? It's called root. Root equals node arg.
Oh, not multiple.
Let's make a default one that doesn't take in anything that does null pointer. We'll say root equals null pointer here. Because I want to test that add node straight from the get-go. I got to go up and put this up top though. I'll go back down to it in a second. Let me just drop this off up there. Put my constructors together. Then my other shit together. There we go. All right, so this is what I've got for my two constructors. One takes in a new node, the other is just doing null pointer. Let's just try doing what we had. Second tree add node should work now. By doing this, it should have set up to root equals null pointer. That should work. Boom. All right. So we wanted to add some more shit in here. Let's make sure I'm gonna copy paste this a few times and just say change that 19. I need a 10, I need a 5. $27. $17. You want to add a number, Juan? You weren't in here for it.
One particular number, yeah, 30.
30? 3?
22, I think it's 22.
We're going with our age. I'm not gonna say it. It was yesterday. You missed it.
It is what it is.
Yeah, happy
I'll get it
birthday.
next time.
You old fuck. All right. Where should 22 go here? So Juan added in a 22. Where's it going on our shit? So we're gonna go right and we're gonna go left. Should go right here, right? Or correct? All right. Cross our fingers. So our add node's not working, right? I mean, we got the if part right, so let's come and look at this. So let's look at this again. We start off, both of them are pointed at 19. And it is not a null pointer, so we say is argument less than temp get data. By doing this, it should be changing root to be a new node. So root should be a node here once we've done the 19. And we know it did the 19, it did a C out of that. So let's call this test 1. I'm going to do a test 2. Let's see where it's going here. And we'll throw in a test 3 here. Let's see where it's breaking. Let's see if it's doing the actual assignment of the new node. So it assigned 10, and then it's assigning 5.
Oh, it's not connecting. You're saying, yeah, you're saying the temp is pointing to the null pointer and then you reset it to a new node, but you never really connected the next one. So you have to say cur is equal to wherever temp is, and then say whatever that is, that's where your new node is going to be. So it's not, it's like creating these new nodes separate from the actual tree itself.
You're right.
You have to do one more comparison and say if it's less than, then do.
Yeah, I really do have to do another comparison. So, oh wait, we can get rid of our COUts now. We know that shit worked. You're right, we're not. Temp is just floating. And I don't need that anymore. We know that's doing it. Did I delete the wrong shit?
Yeah. Right there.
I'm like, if I delete that C out, I ain't gonna have anything left in it. So we gotta do, okay.
Just copy and paste the
But it's not gonna be true anymore. We're gonna have to adapt this. So it's not if arg, we're gonna compare current and temp. And I'm gonna do if temp data is less than, because we've already assigned temp data. If temp data is less than current dot get data, then we're gonna say current set left.
No, something right now that's open. So we're just checking to see if the argument is less than current or greater than current.
Well, we've already made the new node. Like this is making 10,
Oh,
and now we got to connect 10. So is temp get data less than current get data? If so, we're going to do current set left. Yeah, set left takes in an argument. Didn't it? Isn't that how we set it up? So I don't even know that I need this line here. We'll just do set left arg. And we'll change that to arg. And get rid of that. And then we gotta do change this to current set right down here. And that should be a pointer. And it didn't switch to a fucking pointer because it is a rat bastard. Oh shit, it is 6 o'clock, isn't it?
It worked.
We got it working.
That's what mattered. That's a common W right there.
That's a win.
Let's go.
All right.
No.
I'm gonna go home. I'll post this in like an hour. Stop share, stop recording. Peace out.